Hi everyone, welcome to the last and final video of separation techniques. We've saved the best, if not the easiest technique for last. This technique involves using something called a separating funnel. What does a separating funnel look like? This is what a separating funnel looks like. It is not like the typical funnel which you're used to seeing that kind of just stops like that. This funnel kind of continues upwards to form like a bulb shape, right? And it even has a tap at the very base of it. You can see this tap over here. Let me just draw it in the yellow. You can see this tap over here. This tap allows you to allow liquid to run through, or you can stop liquid from running through. Right. To understand what the separating funnel is for, we need to know what kind of things it can be used to separate. Let's go back to one of our previous lessons where we talked about how there are different kinds of liquids present, available in the world. Some liquids are able to mix really well with each other when we say that they are miscible. To say that two liquids are miscible means that, let's say we have liquid A, liquid B. If two liquids are miscible, they can mix to form a solution. This is a mixture. And this mixture is really hard to separate because at the end of the day, how do you separate two liquids that are mingling with each other really well? Right? If they are miscible, it's really hard to separate them. But we've learned that there are two techniques you can use to separate liquids that are miscible. The first is using chromatography. Chromatography makes use of the fact that different liquids may have different solubilities in different solvents. In distillation, fractional distillation, we make use of different boiling points of liquids. Right? That can also help us to separate liquids. What is the separating funnel for? Well, there are some liquids that are, rather than miscible, they are immiscible. Immiscible means that they cannot even mix to form a very homogeneous solution. You're very aware of an example that you encounter quite often. That's oil and water. Oil and water are immiscible. For example, you see oil and water, even if I give it a stir, eventually they will separate out. And you'll find that oil will separate out on the top, water at the base. Not only are they immiscible, the reason why they separate out clearly into two layers is because oil is less dense than water. And that's why it's floating on the very top. Now, if you notice, for every single separation technique, we always look for a particular property that differs between two substances. In this case, we use separating funnel to separate liquids that have different densities. Not only do they need to have different densities, they need to be immiscible to begin with. Right? How do we use separating funnel? Very easy. Just transfer the liquid into the separating funnel, and what you find is that the liquid ends up again separating into their layers. Right? What's going to happen next? We're going to use the separating funnel. Okay, we're going to use the separating funnel, and you see the tap at the very base. What the tap is for is this. The tap can be turned, it can be twisted. Okay, the tap can be twisted. Let me just direct your attention here. This is the tap. The tap can be turned. And when you turn it, what's going to happen is that it's going to allow liquid to pass through. If I were to turn the tap at this point, you'll find that water will be the first thing that will drip through. Because water is more dense, it's going to end up in the beaker first. Eventually, okay, let's let the tap run. The tap's going to run. Right? The tap's going to run, and eventually it's going to reach a point where water is all going to run through, and all I'm left with is the oil. And that's great. Now I've managed to separate the oil from the water. I can simply just take this beaker and then move it to the side. I've got pure water now. If I want oil, I just need to get another beaker. I'm going to put it under the separating funnel. I let the tap run a little bit more. What's going to happen if I let the tap run a little bit more? The oil is now going to slowly drip through the tap out of the separating funnel. And what you're going to find is that the oil is going to end up in the beaker now. Right? That's great. Now I have two beakers. One of the beakers contains just pure oil, the other beaker just pure water. I've successfully carried out the separation technique, and this only works because they have different densities and they are immiscible. And that's really all there is to separating funnel, how we use it and what it's used for. Let's take this time now therefore to summarize what we've learned throughout this whole topic. Right, you see we've come quite far. And we've learned a lot of things along the way. Okay, let's summarize. Let me choose a color to summarize. All right. What have we learned so far through our entire journey? We learned why we want to carry out separation techniques. Right? We begin our question with why. Why even carry out separation techniques? The answer to why we want to carry out separation techniques is because we want to purify substances. Most substances, nature exists as mixtures. Okay, most things exist as mixtures of substances. But we want pure substances at the end, be it pure elements, pure compounds. That's why we want to carry out separation techniques, because we want to get pure substances from mixtures. And I went through with you, we learned together a total of number one, magnetic separation, 2, filtration, 3, chromatography. Then we went on to 4, crystallization, 5, simple distillation, 6, fractional distillation, 7, sublimation, 8, separating funnel. Total of 8 techniques. That's quite a lot. Okay, but always go back to the idea. When do I use each separation technique? Right? At the end of the day, it boils down to a property that differs between the two substances that we want to separate. For example, we use magnetic separation when the substances that we're looking at have a difference in magnetic properties, right? Whether the substance is magnetic or not. We want to use filtration when there's a difference in size. We use chromatography when there's a difference in solubilities. We use crystallization when there's a difference in boiling points. We use simple distillation and fractional distillation also when there's a difference in boiling points. Same for fractional distillation. We use sublimation when there's a difference in sublimation points. We use separating funnel when there's a difference in densities. So at the end of the day, we decide which separation technique based on the properties of the substances. Different substances have different properties and they differ between the substances. By knowing what the properties are, we can decide which separation technique we want to use. And maybe we can now have a look at this particular example over here. What if I have a mixture of copper sulfate crystals that can dissolve in solution, and I add a little bit of sand into the mixture, I add a little bit of magnetic iron into the mixture. If I were to zoom in, this is what you see. I see a lot of the solute. I see some solvent. I see some sand grains that are quite large in size. I see some iron that is magnetic. I see, what else do I see? Okay, and that's all we see, right? You notice now, actually there are many things in this mixture, right? So far, all the examples we've been talking so far, we deal with mixtures with contain maybe 2 substances, very easy. But here we have a mixture that has so many different things. We have a solute here and a solvent here. This solvent probably has a different boiling point compared to the solute. Here we have something that has different size compared to the iron. And then iron is magnetic. So many different properties. But I challenge you now, given that you've learned all 8 techniques, must you use only one technique at any one time? Actually, we taught you all these techniques so that you can use them one after another in sequence and separate out many different things from mixtures that contain many different substances, right? Which of these 8 techniques would you use to separate out this particular mixture over here, right? This is the challenge that you guys will face in the future, right? Learn how to make use and decide which separation techniques you want to use. Learn to use them in combination, one after another. And if you understand the fundamental differences between each component of the mixture, then you can properly decide which separation technique you would wish to use. With that, we've come to the end of separation techniques, and I thank you for joining me on this journey, and I hope you enjoyed the videos. Thank you.